Hello, welcome to Extreme Academy Live. This is where you come to advance your skills, advance your knowledge, and advance your prospects. Thanks for advancing with us. So this is week 3 of the wireless course. I'm going to bring Isaac in straight away. How you doing, Isaac? How's your week been?
My week's been good, man. My week's been really good. We've had some really cold days, but look who's got a haircut. Whoa.
Well, thanks for noticing, Isaac.
You must have been very early in the queue.
Exactly. So everybody knows we're in the UK. Lockdown's easing gradually for us, and hairdressers opened this week. And Isaac, I was the third person in my village to get his hair cut this week, so I felt good. I got in the queue nice and early. So what
Good for you.
what have we got planned for this week, Isaac?
So we're carrying on from last week. I think I got 1 or 2 slides from last week, and then we jump into antennas, which is an interesting topic, really interesting topic. We're going to talk about mesh, wireless mesh, which again is such an interesting topic and has such a broad range. We're going to be talking about international standards and bodies, the bodies that do all these standards, the 802.11. We're going to cover that in quite a little bit of detail, and then we're going to be talking about the physical layer. And again, there's lots of interesting little bits and pieces over there. We end up talking about military radar. So it's an interesting one, really interesting one. Full program, very interesting.
That sounds fantastic. We had some feedback during the week, Isaac, didn't we? We have just so everybody knows, we have a production meeting every week in between the lessons. We talk about things that happened in the previous lesson and what we're going to do in the next one. But we had some feedback that we wanted to address and discuss before we get going. Is that right, Isaac? You want to take the first one?
Yeah. So the first topic is on the issue of the course, or how basic the course is, or so, right? So there's been a few comments about some people find the course a little bit too easy, a little bit too basic, etc. And that's a really good topic. I think on various occasions I've actually said things like, hey, if you're a guru in wireless, this course is not for you, because there's not much that we'll be able to teach. But there's so many people who want to know about wireless, and they don't really have the skills. They hear these terms, but they don't know what we mean. And my objective has always been, when you teach, make things so simple that everybody can understand. I was one of those, and I said in the last lesson, I find it difficult. I don't just, when somebody says that, I don't hear it first time. And so I really make it my objective. And I think that's part of Academy, make stuff so that you reach the broadest audience. Now, if you're one of those people who really know a lot of stuff about wireless, and there's a number of you online, come and help us, come and help us. Be on there on YouTube and answer questions. There's quite a number of people, Miroslav and a lot of, Red Shark as well. You guys have been awesome, just helping other people and just, with answering questions. That's fantastic. It's a really great community. So if you know a lot and you think that this is too basic, don't go away. Don't drop us. Help someone else. You'll feel good when you do something like this. We need to aim as wide as possible and help as many people as possible. So join us on that journey. So that was kind of really the big thing, 8 weeks, people spend an entire lifetime learning about wireless. We're going to do it in 8 weeks, but we give you a good overall knowledge. Now, that was the one thing. And the other thing that came up in that production meeting was a comment that someone put out. I don't recall who it was, but it was a comment about the slides and the content being too small, right? And you want to cover that, because I think you might have responded to it, but can you just maybe give a little bit more light, throw a little bit more light on that, give a little bit more context?
Yeah, sure, Isaac. We did answer it in the chat last week. It came up a couple of times from 2 different people, and the comment was that text on the slides was small. And so we talked about that in the production meeting. We just wanted to give everybody some feedback about what we discussed. So what we're doing is we're taking slideware and we're making it slightly smaller so we can fit Isaac on the screen in the top right hand corner. And that was a very deliberate production kind of template that we're using, because we think when you're watching something on video, it's great to see the presenter, it's great to see the person and see the energy come through. We didn't want to be hiding eyes up behind a slide over and over again. So that's something we deliberately did. A consequence of that is that by arranging the screen that way, we've made some of the slides, when we've got a lot of text on the screen, we've made some of the slides quite small to read in terms of the text, if you're watching on a small screen. So we talked about that. We thought about whether we could do anything, but we when we weighed things up, we decided we were going to stick with a production template, have the video showing. And what we'd recommend is if you don't have access to a larger screen, remember we're on YouTube, so you can watch this on a smart TV if you got one, put it on a games console, put it on any device. If you don't have access to a larger screen, then another thing you can do, a tip, would be just to take screenshots, which we're absolutely fine with. We know a lot of you are doing it. If you use something like Snippet or any application, you can take a screenshot and then you can zoom in. You can look at that text. Now there are some slides, images that are quite complicated, and I think if we get the chance, we'll go full screen on them. But if you don't have a large screen, then we recommend that you take a screenshot so you can take a closer look. All right, so that's some of the feedback we've had, and we'll keep the feedback coming. If you've got any comments about these two topics we just mentioned, just put it in the chat window. Come over to Meeting Pulse and tell us in more detail if you want to. That's just another reminder, just to go over to Meeting Pulse. You'll see the QR code over my shoulder and the URL on screen. Just give us feedback. That's where you can ask questions of the Extreme team. We'll be running some polls there as well. Or just put some comments down in the YouTube comment section if you've got anything you'd like to share with us about those two topics we just covered. All right, that's enough for the intro. So let's get on with week 3, the wireless course. So Isaac, over to you. Let's begin.
Oh boy, this course is generating so much interest. Our viewership numbers are just going absolutely through the roof, and that's all because of you. So thank you so very much for all the likes, for all the watches, for telling people, because we have 300, 400 people online watching this content, and we're getting thousands of views. It's got to be because people are spreading the word, people are telling others about it. So thank you very much. I really, really appreciate it. One little thing I want to say to you. One of the things that I noticed when I used to travel around the world teaching, and that was, I noticed that a lot of engineers, a lot of people, a lot of students who would attend the classes that I would be teaching didn't really see LinkedIn as an important tool for them. It's like, yeah, so what, I'm using Instagram and other things. But I want to just encourage you, if you don't use Instagram as a social media tool, people don't know about you. You might be a great engineer, but nobody knows. What's the point if nobody knows about you? So if you have something to say, if you want to be connected to other people, it's really necessary. This course, we've said this before, it's not just about wireless. It's not just the technical. We really want to help you to build, to advance with us, to grow in your knowledge, advance in your skills. And really, we want to help you to get a better job, or perhaps change job, or even to get a job at all. And having these skills really helps you. But what if you attend all of this, but nobody knows about this? And the reason I'm saying this in specific is we are approaching around about 400 graduates that have got their XNA from the first course. 400. That's really, really great. But that does mean that there's a whole bunch of you who watched the content and haven't written the exam yet. So let me encourage you, go write that exam. I know it's not easy. People say, oh, well, it's just going to be easy. No, it's not easy. A number of people haven't passed it and had to have a second go, at it. So have a go. If you fail first time, have a go, have another go. And if you fail the second time, send an email to Claire. The email address will appear, on the screen. Send her an email, ask her for a reset. We'll give you another go. have a go at it. And when you pass that, go onto LinkedIn. You know, if you don't have a profile, create a profile. If you have a profile, when you pass the exam, put it on there. I've passed. I will try and track you myself, or Rowan, or one of the others, and we'll just, you know, send you a comment so that people know, people in our networks say, oh, okay, so there's somebody here in Chile who knows, or there's somebody here in Lima who knows, or somebody here in, you know, Slovenia who's done this course. It's really useful to you. So you got these tools, use them. Thank you for everybody again who's liked our comments, who's liked my posts, and those of Extreme Networks. It's so important, and thank you. It really gives meaning to what we're doing, right? We want to help people, and when we see the comments coming in, the stories, the emails, when I read your posts, or people who respond to me directly, you ask me questions directly on LinkedIn, it's really fantastic. I really like that, and I really like communicating with you guys and hearing your stories. So tell us your stories. I'd be happy to hear. Tell Claire your stories. This week I got one or two posts, but one of them specifically said, wow, only 2 lessons and I've already learned so much about wireless. Fantastic, brilliant, good for you. Okay, so in the last lesson, we finished on this. Slide. Now, again, I'm going to be looking down occasionally because I need to draw on the screen, for example. So you'll be looking at me drawing over here. So what we're talking about here, what we've been talking about, is radio signal. So in the last lesson, if you haven't watched it yet, please go and watch it. I talk about radio waves. How do we see radio waves? How is it that in our mind we can see what a radio wave looks like? And if you can get that picture and you start to realize that all around us, all the time, we are surrounded by radio waves from all types of sources. And if you understand that, then we started to talk about the properties of radio waves. And so we spoke about absorption and deflection and scatter and diffraction, right? Diffraction, where it changes direction. So here is a good example. This slide is a good example of it. We have a building, you know, there in the middle. Let me see if I can get that pen going. And that's really nice. I'm trying to get the pen going and it won't go. So let's try once more. Oh, now I have the pen. Okay, so here we have a building. It could be, you know, any building, the office where you work, for example, and we have an antenna. And after this, we're going to get into antennas. And you can see that what happens as this antenna broadcasts, as it transmits, you know, its signal, just like in the water, when that log fell in the water, as those waves go out, you'll see that it hits, you know, it hits barriers, right? There's a wall over here, and then there's another wall over here, for example. It might be a wall, but there's a building over here. And in this case, of course, some of the waves are going to go into that building. We've seen that, right? They will go through the wall, and they will have some attenuation. There'll be some loss, and they'll go through, and they'll get through on the other side. But some of these waves are going to go past there. They're going to hit that wall, and they're going to be diffracted, okay? There's going to be diffraction. So this being the original direction, then it hits that wall and it starts to go in another direction. The same thing happens over here. Look what happens here. It hits that wall and it changes direction and starts going this way. So if somebody is sitting over here, oh man, that's a really bad drawing. that's even worse. I think I'm just going to stop drawing. So if somebody is standing over here, they're going to be getting a signal even though the antenna was aiming in that direction. You might also, of course, occasionally have this type of situation where you just have like a shadow, right? There's no light that appears in that shadow. And so you might have those dead spots. And you see these a lot. You experience these a lot when you have mobile signals, right? You get certain spots, there's just no signal, but you move 1 meter and suddenly you got, 4 bars or 5 bars. So remember, radio waves have properties. This is one of those properties, diffraction. Okay. RF propagation. RF, remember, radio frequency propagation. When it travels. That propagation means when it travels from point A to point B. Now, we have spoken about free space path loss. Basically, physics dictates that as a radio wave travels in time, it's going to gradually lose power. Think about the signal for Wi-Fi, right? The little dot in the middle, then it's got those little lines. To draw that correctly, actually, really accurately, those little lines, those little half lines like that, they should decrease the width of them as those lines progress, right? So you should have the dot in the middle, the antenna, and then those little lines, they should get gradually thinner. Why? Or narrower. Why? Because as the radio signal goes out, right, it increases its range. So it gets broadcast, it goes out, and it increases its range. But as it does that, it also loses power. Remember, think about, back to the example, course lesson 2, the log that went into the water. As it went into the water, it produced this wave of energy that started moving. But as the wave went out, that wave got less and less and less. Yes, until when it got to the end, it was just a little ripple. Same principle, same principle. So there is a simple, what we call a simple inverse square law. Whenever I read simple, I get really worried about, yeah, sure, simple for scientists, right? But it says that that symbol, by the way, is the symbol for directly proportional. That's what that symbol actually means. So we say over here, power is directly proportional to 1 divided by the square of the distance, right? So in free space, power is directly proportional to 1 divided by the distance. So if we say 1 divided by 2 meters, well, 1 divided by 2 is going to give us a half. Yeah, okay, we know that. But if the distance is 10 meters or 20 meters, then the calculation has to say 1 divided by 20. And obviously, in that case, you're going to see that the value is going to be much smaller. So you can use this type of calculation to start figuring out, if you're building a scalable and a robust wireless network, where are where are your clients? Where are the people that are going to be using your wireless network? Is it a warehouse, right? Is it the football field, people in a stadium? Is it in an office? So these are the things we need to think about. So in free space, in an open football field, in an open rugby field, soccer field, we know that that's the calculation, right? 1 divided by the distance squared. But indoors, it's not so simple, okay? There's not such a simple law. Empirical studies, now I had to go look up the word empirical. I didn't know what it means. Empirical studies mean by observation, right? By observation. In other words, not done in a laboratory with equipment, but just by empirical study. By observation, we know that indoors, it's not the same. We certainly do not get the same range indoors as what we're going to get outdoors. And the clever people say to us that indoors, this is kind of the formula, right? The power is directly proportional to 1 divided by the distance to the power of n, where n is between 2 and 6, the value of 2 and 6. So you can then see that if I start to do this division, that imagine 1 divided by 2 to the power of to the power of 6. Well, that's going to give me a lot of zeros. Make sense? Okay, good stuff. Okay, Multipath distortion, another one of these terms. So I'm going through different terms that you need to become familiar with. If you're taking down notes, this is stuff for you to go into Wikipedia, and there's lots of other sites where you can go and find this out. So if you're going to get an interest, develop an interest in wireless, these are terms that you need to be familiar with. You need to understand this. Now, I am not covering this in all the detail that's possible. This is, I only got 8 lessons to cover all of this. I'm not a genius and I don't know everything that there is, but there's an enormous amount of information. So when you see these titles over here, like this, multipath distortion, reflection and multipath, write those things down. Because then you can go, when this lesson is finished, you can then go read a little bit more on it and learn more, back up the knowledge that I'm activating in you and base it, give it a good solid foundation. So here, let's take this boardroom, right? A simple boardroom. We have a client over here and we have an access point sitting in the corner over there. Now, the client and the access point might have one antenna. Generally, they don't do that. They would have 2 or 3, antennas built into them. But when this client is wanting to talk, right, that signal is going to bounce in a number of different ways, just because of the properties of radio waves. So we have the red, we have the black, which is the direct line of sight, and then we have a green as well, another reflected one, right? It hits the wall and it bounces and it hits that access point. Now, that could be a problem because the access point is now receiving these signals, the 3 signals. So look at that over there. We have the black, right? And then we have the green and we have this red radio signal. Now, in a couple of slides back, we spoke about when waves are in phase and out of phase, right? In phase and out of phase. So if you have a wave that is exactly the same, the same hertz, exactly the same path, but arriving at slightly different offsets, you get this thing that we spoke earlier, which is out of phase. So this radio on your laptop, on a device, is transmitting, is broadcasting. Because of the properties of radio waves and because of the room that you're in, one of them is going to get, the access point is going to get that first, and then it's going to have these other 2 arriving on the other antennas at slightly different offsets, right? The resultant signal might look something like this because they're slightly out of phase. And so the demodulator that's got to now take this radio wave and convert it back into zeros and ones might have a little bit of an issue. There's also a positive here, of course, that the radio can pick up the strongest of the signals and go with those ones. But you get an idea. We're talking here about radio waves, their propagation, how they move around, how they bounce, and the types of things that you have to consider. If you thought that you just put an access point in an office and everything is going to work hunky-dory, it might work. You might get lucky. You might have no issues at all just because of the nature of the access and where you put it. But it might not be that easy. And if it isn't, you need to sit down and say, what am I doing wrong with this access point? Why are users sitting 2 meters away from the access point, but some are getting good access and some aren't? And then you have to start thinking about these things. Remember, designing wireless networks, robust, scalable. Why? Look at that. Think about the deflection in the room. Think about what's happening to that radio wave as it leaves that transmitter. Again, this is one of those slides that I don't want to spend a massive amount of time over here because I'm going to cover this in detail. I might just even do this in a supplementary lesson. But let me just do so. Oops! Oh man, I lost that again. There we go. So we have to have a way. Remember, when we talk about radio waves, we use the term watts, which is a measurement of power, but in radio, when we talk about the measurement of the actual power, we use decibels. Okay, dBm. We use decibel, dBm to do that. And here you can see 1 watt, 1 single watt is 30 dBm. Now, milli, thousand, right? 1,000. So 1 milliwatt, we base that and we say that is 0 dBm. So we kind of zero it and we say, okay, so we have 1,000 milliwatts equals 1 watt. 0 dBm is one of those, 1 fraction of 1,000, 1 fraction, 1/1000th of a watt. 10 milliwatts, 10 dBm. Look here, 1 milliwatt, 0 dBm, 2 milliwatts, 3. Why? Because we use a logarithmic scale. It's not a direct line that just doubles as it goes. 4, which is double 2, is 6, right? That's a natural doubling over here. But look at that. 8, when we double the milliwatts, that gives us 9 dBm. Logarithmic, right? We use the logarithmic scale for this because otherwise we would be dealing with millions of zeros, to try and talk about milliwatts and all of these, and it would be really, really difficult. As it is, we talk about minus 80, dBms, and then if you start to convert that back into milliwatts, that's 0.0000. Yeah. So a signal greater than 1 milliwatt, 1,000th of a watt, we give it a positive. And if it's less than 1 milliwatt, we give that a negative dBm, right? This is very important. I want you, if you write it, if you remember it, do something, but make sure you get this statement into your head. The more negative the number is, the weaker the signal. This is very important. This is almost as important as that slide on course 1, lesson 1, where I spoke about how zeros and ones get converted to positive and negative on an electrical pulse. If you remember this, then so much of the other things that you're going to see in wireless are going to make sense. The more negative it is, the weaker the signal. And here's that logarithmic that we were talking about. A 3 dBm gain, power is doubled. A 3 dBm loss, power is halved. Very, very important. Now, receiver sensitivity, the receiver, right? An antenna receives, just like it broadcasts or pushes out the signal, it also receives. And these antennas will have sensitivity. Remember the example I spoke about humans and about dogs. If I'm talking to you and you're next to me, you can easily hear me at the volume I'm speaking at, right? But if you move 10 meters away, it becomes a little bit more difficult for you to hear. But not for a dog. Why? Because their receivers are a lot more sensitive. So sensitivity also affects the range of a radio frequency signal, and certainly the quality of a radio frequency signal. So look at this. If we're talking about 802.11n, 802.11, remember there's lots of these different revisions and we will cover them in a little bit later on today. Then at a distance of 66 meters, which is okay, that's already quite a significant distance. We're going to get a radio signal of about minus 89 dBm. Minus 89 dBm. Now figure that out in milliwatts. It's very, very, very small. Okay, minus 89 dBm, and at that rate, we're going to get about 1 megabit per second. That's it. Nothing more than that. Look at this. At 52 meters, okay, 52 meters, that's 14 meters, the signal strength rises to 82 dBm. And there we can get 6 megabit per second. So this is telling us that the stronger the signal is, yes, the more throughput we're going to get through. Look at this over here. For 84, remember again, this is 802.11n. We're just using this as an example. 802.11n, you can get 84 megabit per second where the radio signal is minus 53 dBm on a range of 14 meters. So the further you go away, the less throughput you're going to get. Right? So the sensitivity will then determine, hey, I can't, this over here, at this rate, 66 at 66 meters, I can't give you a better signal than 1 megabit per second at that rate. That's the best signal that I can give you without going into a world of retransmissions. Sorry, can you, what's the point of trying to talk fast at 66 meters away if the other person can't hear you? So rather slow down, say one word at a time. Slow down, then I can understand you. Okay, I know it sounds basic. A lot of this stuff is basic, but a lot of this stuff is really, really useful to know. We've covered this again. I'm not going to spend time on this. Basically, if you have a lot of background noise caused by interference, then what's going to happen? That background noise goes up, and then the signal noise, has to be above a certain level. Otherwise, there's too much interference, and it's going to be difficult with a radio wave, for example, that same radio wave where the noise drops, then it works absolutely perfectly, typical Wi-Fi signal, minus 10 to minus 70 dBm, typical Wi-Fi signal, and then typical noise floor between minus 80 to minus 100. Okay, let's go a little bit into antennas. Equivalent isotropically radiated power, EIRP. Last week I gave you some homework and I said go and read some information on an isotropic antenna. I should have used the term isotropic radiator. That's a kind of a better term, isotropic radiator. So an isotropic radiator is a theoretical radiator, a theoretical antenna or radiation source. Why do we say theoretical? Because it's theoretical in the sense that it is a perfect sphere, right? A absolutely perfect sphere that radiates in all directions perfectly, equally. Now, is there such a thing? No, there isn't. It doesn't exist. If there is, we could probably say that the closest there is to that would be the sun, right? Think about that. The sun. It's not suspended in space. There's nothing holding it in place. There's no bracket holding the sun in place. It's suspended in the universe, and it gives out energy in all and every direction perfectly. We haven't built antennas like that. Like that yet. So the effective output power, okay, in dBi. Now this is another term, dBi. Why I? Because it stands for isotropic, okay? So it's modeled on the isotropic, the theoretical model. The effective output power is measured in dBi at the antenna. This is very important, right here, and includes antenna gain. So dBi gain at the antenna as compared to an isotropic radiator. So if you had this theoretically perfect, which we can calculate for what a theoretically perfect model is, then dBi is the gain at that antenna when compared to a perfect isotropic radiator. Now the output power of a transmitter is measured at the intentional radiator in dBm, the set of components broadcasting radio waves. A little bit confusing, right? dBm, dBi, milliwatts. I know. One of the things about wireless is it has a absolute ton of terms, and it's a little bit tough to get your head around all of these. Again, I really encourage you, go and read up these terms. Go and read up intentional radiator. Oops, IR. Okay, very important. This EIRP. So we have a bridge, it has a connector, it has a cable, another connector to that cable, to the connector, and then finally to the antenna. Now, in an access point, this might all be built in, right? So this cable and that might not exist inside an actual access point. But I'm using this example over here because not all access points have internal antennas. Or if they do, there might be many instances where you want to use an external antenna, right? If I wanted to link my house to my garage and I wasn't happy with the attenuation, the wireless signal coming through that door of the garage, through the wall of the garage because the drop was too much, I could always put an external antenna on both buildings, right? And we're going to cover that. We're going to cover directed radio signal. So we could do that and direct the signal. And in that case, there would be a cable that's coming out connected to the back of my access point, and it would run X amount of meters before it got to the actual antenna, which would then boost the signal and push it out at a certain rate. So these values, so here's the external antenna, that would be the internal antenna. These values are strictly regulated. I think most, like the American regulator, and I think the European regulator, I think the maximum that an access point can have, or most access points I think, are 20 dBm. That's the maximum power that they're allowed to have. Otherwise, they're going to flood everything in the area. All right, if that wasn't regulated, you're going to have a big issue, right? Because then everybody does everything and no one can communicate. So there are these rules and regulations in place that will make sure that you can only go to a certain level. These things are strictly regulated. For extreme networks to get an access point certified, it has to meet those regulations. You can't just go, oh, well, I don't care what the regulator says. I'm going to put 100 dBm, a dB power on this particular access point. No, you're not. So antennas. You've all seen antennas like this one on the left, right? You've all seen these types of antennas on top of your roofs. In South Africa, we had these when television still first appeared. That's what we have. They are directional antennas, and on an actual access point itself, like some of our access points, you will see they will have two radios, radio 1, radio 2, and each radio will have two frequencies, right? So this one, for example, it could be 2.4 or 5, and that one, that could be 2.4 or 5. And you can change that. You can say, okay, for radio 1, I want it on 2.4, and radio, and then on the other channel, I want 5. Or you could have them both on 5. So you can kind of do things with some of ours. And then this one, it even has a third antenna, which is the BLE. We call that Bluetooth light energy. So here we go. There's the perfect isotropic radiator, the sun, right? Theoretically perfect, radiating power equally in all directions. Well, we wish it was. It doesn't actually exist. This is an isotropic, antenna. So here, between there and there is no gain. All right, because that's what it is. It's a 20 dBm. There's no gain within that particular region. Here is the gain. Right, that distance, that is the gain. So this is antenna with gain. So real world antennas, I mean, not theoretical, the real world antennas are measured against a theoretical, right? Complex mathematics, not for this course, not for my head, far too complex for me. And then decibels over isotropic, that's that dBi I told you about, is a measure of the amount a real antenna differs from the perfect theoretical antenna. Real antenna have gains quoting in dBi. Okay, so good stuff to go and read up on the internet. Understand, help you to understand. So when you design networks, these figures here are going to be really important for you so that you understand. Now, you have two types of antennas, two broad categories of antennas. The one is what we call an omnidirectional. Omni in every, in every directional. The same thing like we have microphones. So in front of me here, I have a microphone. It's a special pro podcasting microphone. But it's, when I say podcasting, it's not the same as, the Yetis and things like that. Why? Because when I go and look at the specifications for this microphone, that drawing that you see over here, this drawing over here that you see in there, you get these in the specifications of microphones. And what my drawing looks like is like a half moon. So basically what it's saying is I can pick up the majority of the signal that I'm going to pick up is going to be in front. When you hold the microphone in this direction, the majority of the signal is going to be in front of me. Yes? An omnidirectional will have that pattern, will have this pattern over there, right? So I will pick up any voice anywhere around there, and that's why you would use it in a studio. Put an omnidirectional, people sit across the table from you, no effect on the microphone. The microphone hears me and them the same way. If you came into my room now and you sat opposite me, my voice would be really good, yours wouldn't, right? Because of the pattern. So omnidirectional, that's the pattern. Now, think of this almost like, a donut, right? A donut. If I were to look at it from the top, the azimuth pattern would be almost perfectly round. It's not perfectly round, you can see. It's almost perfectly round. But that would be a pretty good omnidirectional antenna, right? And then this one over here, you can see that's if I then cut it, slice it the other way, slice that donut the other way. That's the pattern that you see. Now, for most of these antennas, for most microphones, for example, when you purchase one, you can go and look at the specs of that particular antenna. And for every one, you will see these diagrams. They have to get an access point certified and the antenna certified, they have to go through this process. They have to produce, Extreme has to produce this to show a customer what exactly this pattern is. Now, if you are building scalable, robust wireless networks, you're going to have to know this, okay? You're going to have to do this, because once you've figured out where is this antenna going to go, where is this antenna going to sit, what location, and it's not just going to be one. You might have 20, 40, 100, 200, 500 access points. It might be a hospital. Some places are going to be in offices. Others might be in the patient rooms, where the patients are. Others might be in a theater. So every office or every room or every ward in a hospital might have slightly different requirements. So that's why you can't just say, oh, one access point is going to, we're going to use this one access point all over. For certain places, that might be the case. But when you understand where you're going to be installing access points, the locations, the configuration of the room, what you have inside the room, then these things come into play. So, okay, so I'm going to need in a hotel room, I don't need a directional antenna. It's like, it has no purpose at all. I'm going to need an omnidirectional, because the person in the room might be moving at any location. So I need to cover as broad a range as possible. So again, these are things that we need to think about. Some of you might know this. You're like, oh, this is so boring. But from the comments and that people have already sent to me, I know that to many of you, now that you've seen this and have this explained, it's like, Now I understand. Now I got what that means. Now I can interpret that. I didn't know it was cut this way or cut that way. Now I can see what's doing. Now I know that that directional antenna I bought, it's useless. That's why only one person can get access, right? Think about these things. Right. So there's the omnidirectional antenna. Well, might look something like that. Now, in a mobile phone, you have antennas as well, right? The very first mobile phones that came out, the like Motorola's and things, they had an antenna that sat, on the top, and you would pull out the antenna. Then they developed something called patch antennas, which actually are flat and fit inside, inside a mobile phone. So nowadays you can't see antenna anymore. I think on the iPhone there's kind of like a little line that runs along the body of the antenna, but you kind of get the point, right? Antenna is sitting inside this device. It can be really small, but it's doing this job, okay? It's omnidirectional antenna. And then you get these again, like those TV ones that you often see on top of buildings, on top of apartments, on top of houses. These are directional antennas, and this part over here, this is what you are aiming at the transmitter. So if I go up to the top floor of my house, I can't really see it, but there's a couple of sites here in the UK where you can go and say, what's the closest transmitter to Cambridge, and they will give you a GPS location. I'll say, okay, the closest one is in this particular direction. And why is that useful? Because if you're mounting antennas, then this piece here of that antenna, in other words, this piece here is going to be pointing at that transmitter, at the angle that transmitter is, because it's a directional antenna. It's no use you having an omnidirectional antenna. It doesn't make any sense. For this purpose, it's it's directional antenna, and that's what this thing is. It's called the Yagi antenna. Invented by a Japanese guy, two Japanese guys, I think, one of them called Yagi. So the directional antenna, it focuses the energy. Patch antenna, like I mentioned, that's what you find nowadays on the inside a mobile phone. So what are the criteria for installing antennas? If you're going to have antennas, or just thinking about the antennas inside access points, or possibly internal and external. First of all, when thinking about antennas, the types of antennas, right? That's an important thing when you start to plan about where am I going to install antennas. Think about what type of antennas am I going to be using. Do I want a directional or an omnidirectional? That's one of the questions you need to ask yourself. What about the data rate? Okay, what about the data rate? Is it okay for me to have a 2 megabyte connection? Is that okay? Or do I need absolutely maximum throughput? Now you might think, oh, I absolutely need to have maximum throughput. But it's not always the case. A baby monitor, for example, might not have to be connected at 500 megabit per second. Yeah. A baby monitor might be, 15 megabit per second might be fine. So is the circumstances correct? Is that what I need? If it is, that's what you need to do. In a LAN-to-LAN network, the distance between the buildings. So if you have, and we'll cover that just now, if you have two buildings and I have like my house plus my garage, the distance from building to building is about 6 or 7 meters, more or less. I haven't measured, but I'd guess about 6 or 7 meters. That's not a lot of distance, right? That's for wireless. But maybe you have a school building or university building and you can't dig to roll fiber or whatever. Then you have to have a directional antenna from one point to the other point. Then you got to think, how much bandwidth do I need across there? How much distance do I have? Will I, if I've got 50 meters, will this antenna be enough to get a 100 megabit connection across that on a 50 meter? Now you see how DBIs, DBMs, how the antenna pattern, how all of those things come into consideration. It's like, now I got to think about those. This little cheapo £89.99 AP is not going to do the job, right? Because the requirements mean that that thing is not going to do the job that you thought it was going to do. What about obstructions? Well, obviously, right? If between my house and my garage I had a big steel wall, or whatever it is, well, we know that we're going to have issues. We've already looked at the refraction and diffusion and all of those things. Now, in a wireless infrastructure network, the area around the antenna where clients need to communicate. So, generally in office environments, especially modern ones, they attach access points into the ceiling, right? It's normally a dropped ceiling, or I think we call it a false ceiling. And so those cover that whole donut shape, omnidirectional, absolutely fantastic. So if that's where the majority of your people are going to be, that's what you need to be. The placement, where do you place that? That would make the best sense. Now, just because I say that makes the best sense doesn't mean that it's always the case that makes the best sense. Every consideration, every project that you as an engineer are going to be involved in, you have to think about all of these things. Even though you might be a home user and you might be interested in this course as a way just to learn, how to fit wireless in your house, the knowledge that you learn from here can be taken to so many different areas. But there's a big gap between home use and enterprise use, corporate use, right? At home, one access point, the cheapest one that I can do, put it in and it works. Enterprise, it's not like that. You got to think differently. In a hospital, it's people's lives. It's access to critical information. It's schools, it's education, it's access to resources. It becomes a totally different ball game. So directional and omnidirectional antennas, you'll see them often installed on rooftops. Directional antennas would also often be installed on the sides of buildings. So in my house, if I wanted to put a directional antenna, I wouldn't put it on the roof, right? Because it's a 2-story house, so the roof would make no sense at all unless I managed to find a way to aim it particularly down. A much better way would just to be put it outside. And that then brings in other things, right? Like weatherproofing. It doesn't make sense just to say, well, I'm going to put an antenna outside. Well, if it's a directional antenna, it also has to be a weatherproof directional antenna. No. I'll cover the antenna, with the steel housing. Right. Here's another, access point. This one is an external one. You can normally tell by these things over here, right? Those are like the weatherproof seals, to power something like that. This one would have, 2 radios, radio 1, radio 2, and these both have digital signal processors on them, and then connected off to the antenna. We'll use this term, and you'll hear this more and more as we go, MIMO, okay, or MU-MIMO. Multiple input, multiple output. That's what these things are saying. Multiple input, multiple output, right? 2 radios, inputs coming in, multiple outputs going out, and giving you spatial streams. And we'll talk about this in more detail. I just want to give you an overview at the moment. Now, if you want to know more about antennas, about aerials, about the stuff that we use on our access points for extreme networks, right? Because every vendor is going to have their own stuff. But if you're interested and you want to read more information, then just go onto our website and go and look at this guide here, Extreme Wireless Antenna Specification Guide. It's updated reasonably often as specifications change, as more products are added to this. Go and read this. It has an enormous amount of information, compatibility matrix, indoor access points, outdoor access points. You get all of this information in this particular guide, and most vendors, most decent vendors are going to have the same thing. thing. So we've come to the end of this. Ooh, I forgot to give a break. A 1 minute break. Oh my goodness, I'm so sorry. Ugh. I'm sorry, I'm really sorry. So we've come to the end of the session. It's a 10-minute break. Get up and stretch extra, and we'll see you back in about 10 minutes. Cheers.
My name is Chip Suttles. I'm the Vice President of Technology for the Seattle Seahawks organization. The first challenge I was given when I was brought on board with the Seahawks in my role as the Vice President of Technology was, let's solve the connectivity issues that we have at the stadium on game day for our spectators. And the solution, one of the solutions we wanted to bring was a Wi-Fi solution that we could provide and supplement the cellular coverage with a Wi-Fi solution. And Extreme has been that partner for us for the last 4 years in helping us meet that need for our connectivity on game day. We spent 18 months investigating all the products on the marketplace, and it was a very competitive landscape. Extreme set itself apart because they were newcomers to the field, but I think the relationships and the people made the difference and set themselves apart, and they were competitive in pricing, but more so they had a solution that we felt was going to work for us for long term. To me, it's been a higher level of customer service. For one, I feel like I've been brought into the family. I know the members of Extreme from the CEO through the whole management team. I've been asked to be a part of their customer advisory board, which has been fantastic, that they're taking the time to hear the customer feedback and modifying their product line to meet our needs for now and for the future. So it's been a great vendor, great partner to work with, and Seahawks are glad to be associated with Extreme. One of the things that I would say about Extreme is it separates them from other vendors and other solutions out there is the people. In 4 years, I've had the same account management team. I've been working with the same management folks at Extreme, and it's been very consistent in their approach. And again, they've made themselves available to us. They're easy to talk to, and just helpful in every sense of the word.
Extreme Academy was created with one purpose in mind: to help educate and inspire you, the next generation of technologists, and prepare you for the workplace. Welcome to Extreme Academy. It's really exciting to know that as you're watching this video, this is your start of hopefully a long and prosperous career in IT. Extreme Academy aims to welcome you into the industry, give you valuable and relevant knowledge, along with certifications that are going to help you stand out. Our courses require no previous knowledge in networking and are designed to give you the foundational knowledge needed, the bedrock to build upon as you take your next steps into the IT industry. You will also learn where the industry is heading and skills for the future, ensuring that you're equipped with your first job or whatever comes next. Across the Extreme Academy courses, you will have the opportunity to learn about how networks are built, managed, wireless technologies, network design considerations for different environments, the power of capturing data, and much, much more. But Extreme Academy isn't just about learning and knowledge. It's about gaining skills that help you get your first job in IT and help you thrive in your career from day one. Extreme Academy courses provide you with a qualification and evidence of knowledge through an industry certification. This is important because 91% of employers believe IT certifications play a key role in the hiring process, and that IT certifications are a reliable predictor of a successful employee. Furthermore, certification helps you reach higher starting salaries, and certifications on your resume will help you stand out. It's a smart move to get training and certification in networking and skills that underpin artificial intelligence. Artificial intelligence will create more jobs than it eliminates, reaching 2 million net new jobs in 2025, according to Gartner. And as you start your journey into IT and networking, my advice to you while you're developing your career is this. First, surround yourself with people that you believe to be smarter than you. This will help push your knowledge, your understanding, your skills, and before you know it, you will be the expert leading the pack. Second, test your knowledge by teaching friends. There is no better measure of how well you know a concept, a technology, an idea, than when you have to teach it to somebody who knows nothing about it. And third, never lose context of your why, your purpose. If you have a passion in IT and technology, you will never work a day in your life. We can't wait to get started with you and are looking forward to hearing about your stories and job successes being hosted as part of Extreme Academy. It's worth mentioning, this is the first of many videos coming your way from familiar faces all around Extreme Networks, helping you learn more about networking and the industry at large. Make sure you subscribe, click that notification bell, and more videos will be served up to you as we support you on your way to becoming an Extreme Networks associate. And finally, remember this: investing in knowledge is investing in yourself.
Welcome back from the break. Ready to go. Part 2. So, Wi-Fi. This term Wi-Fi, I'm sure everybody talks about Wi-Fi. I mean, I know in French a lot of people say Wi-Fi, but actually, I think most places I've been to around the world, we talk about Wi-Fi. And this logo that you see on your screen is also instantly recognizable no matter where you go. But Wi-Fi really is a generic term, and it's used to describe a collection of low-cost technologies, right, and protocols that enable secure transmission of local area network data over the air. The name Wi-Fi in itself, it doesn't have any meaning. I used to think it used to stand for wireless fidelity. Actually, it doesn't stand for that at all. It doesn't stand. It's just a totally generic name. It's an arbitrary name. It was selected by the Wi-Fi Alliance, really as a marketing thing. It's much easier to say Wi-Fi than 802.11 and all of those types of things. And people, remember this. I think it's a great logo, great name, easy. Anybody from China to Chile can pronounce that name. So it was established around 1999, the Wi-Fi Alliance. One of the things that they do, and they came into being because the 802.11 standard had quite a bit, or has quite a bit of ambiguity in it, right? And so what happens is vendors immediately began to write, their own, adjust the technology to work on their own access points using that ambiguity. And suddenly what you had is you had vendor A's access points not talking to vendor B, and it allowed vendor A to lock you in to their standard. Problem is, if somebody came in with a laptop from vendor B, then it wouldn't work on the network. And that goes nowhere fast, right? That was the old way of doing things. Nowadays, we need to cooperate. We need to, especially in the world of internet, we need to make sure that things work right across the platform, that there's compatibility. So these guys really came in and did the fantastic job, because one of the jobs of the Wi-Fi Alliance is that they certify vendors' products. They certify that vendors' products meet their standards, that mean they are compatible with everybody else's products in the market that have this particular logo. So nowadays on a lot of the access points, if you look on the back, they have that sticker, the Wi-Fi Alliance sticker, and that certifies a product as having met, there's probably other regulatory things, but having met the standards that you could have a Wi-Fi device from this vendor and put another device from that vendor, or a wireless access point, a laptop or mobile device, whatever, and they would work with all of these things. So really important. So they were the guys, like I said, that did the the name the Wi-Fi, which I think was a great different thing, a great thing. Now, Wi-Fi is made up of a different number of technologies and techniques, wireless radio techniques, a whole lot of them. It's not just one particular thing, right? You have the international, the ITU-R. It's the International Telecommunications Union. And they work together with bodies like, in the US, it's the FCC. You'll see this also often on the back of devices, the Federal Communications Commission. And so this body, the ITU-R, they work with these regulators in the different countries or bodies, like in the EU or in the FCC. And they set the rules, okay? They set the rules for what a user can do with a radio transmitter. Now, you might think, yeah, but they're controlling it. But thank goodness that they do that job. Imagine if they didn't. Imagine if it was a free-for-all. Imagine if anybody could use any spectrum at any time and do whatever they want at any power. It would just be a total radio spectrum nightmare. So thank goodness for a body that works together with these regional organizations, and they decide what you can or cannot do with a radio transmitter, and that ensures safety, right? Our safety, because if you had an earthquake warning, if you had some sort of a device, that was going to provide you a warning, but you didn't hear it because your neighbor, his access point is set to 50 dBm, whatever, and it just floods your. Do you understand? So these organizations, these standard bodies are really important. So the International Telecommunication Union Radio-R radio is really, really important in all of these, as is the IEEE. So the IEEE, as we know, also the 802.11 standards, come from there. So all of these different bodies, they all have slightly different angles, slightly different aspects that they control of the wireless technology, and this is really, really important for us. Now, it is fair, it is true to say that in many aspects, Wi-Fi is more difficult, more challenging than wired networks, right? And that's quite easy to explain, because if I need to hook up 100, 200, 300 users in a building, it's really easy. I mean, even if the condition, if it's hot, if it's humid, if there's a lot of metal in the building, if you're going to wire everybody up, it's really easy. One Ethernet cable to every desk, one Ethernet cable to every IP phone, one Ethernet cable to a main printer. It's really easy to do. You got to understand the OSI model. You got to understand how packets work backwards and forwards, but it's really quite simple when you compare it to wireless. Wireless, you're starting to deal with waves, radio waves, right? You can't see them. You can't see how they're bouncing off. They are. You know that there's diffraction, but you can't see the diffraction. You assume, okay, so this is probably going like this. Now, I know that there are sophisticated tools, but they're not as cheap as you walking over to a cable and seeing, oh, this cable is unplugged. Let me plug in that back in. Do you know what I'm saying? So some of the techniques, some of these technologies, you really do need degree level engineering to understand and to master. It's not for this course, right? But if it interests you, it's a fantastic area for you to go into. It is absolutely fascinating, and that will make you a high net worth individual, yeah, when it comes to jobs and stuff, if you understand all of this thing. But for this course, we don't really need to worry too much about that. So what other things are there? What other things make them a challenge? It's the technologies. The number of different technologies and techniques that are used. In a sense, it's like security, right? If you speak to a security expert, they will swear that just implementing this solution will solve all your security issues. And then you talk to somebody else and they say, no, that's completely rubbish. Do it this way and they will solve all your security issues. Wireless, in a sense, is like that. People have best practices that they've learned with experience, and they might say this technique will be better here. And someone else might have a completely different technique, which might also work. Which one is right? The answer is both of them. Both of them are right. And that makes it a little bit difficult, because we kind of, as humans, we want to say, which is the right one? Well, the answer is it depends. It could be either one or neither one, right? So there's a wide range of technologies. There's a wide range of techniques. You really only need an appreciation of the one that is most relevant to what you are going to do. So if you are going to specialize in putting Wi-Fi in hospitals, maybe that's you. You're not a career person, but you're thinking about starting a business and you want to focus on hospitals, then you're going to have to get familiar with the technologies in hospital, with the architecture in hospitals, with the issues that you will encounter in hospital, data protection, all of those things. You have to think about that. So Focus on that and become brilliant at that, rather than trying to know everything about everything that there is. Find an area and specialize in that area. Learn all that there is in that area, because those key technologies are what's going to be important to you. Unless, of course, you're going to go and become a super duper engineer that's a specialist in wireless and you understand all of these things. Then by all means, fantastic. The other thing that makes it difficult is, just as you think you've got your head around all of these technologies, along comes new technologies, right? Oh, now I know everything there is about wireless 5. I'm such a clever guy. Great stuff. Nobody knows more than me. Boom, wireless 6 comes out. It's like, oh, I have to learn everything again. Not really, because it builds on what you have before. But just as you've got your head around wireless 6, then we have wireless 6E. And then when you've got that to 2024, we probably look at the next iteration of that. So I've said this, I think, in one of the very first lessons in course 1. If you're the type of person that doesn't like change, if you're the person that doesn't like things to evolve constantly and change and grow, this is not the industry for you, because this industry moves at pace, and wireless moves at an incredible pace. It really, really, really does. Keeping ahead of all these terms and these terminologies is incredible. The amount of terms that you have, oh my word. Take a look at this. This is one book. This is one book, just one. How many terms do you think there are inside here? And that's just wireless. That's just one book on wireless, okay? There are over 400 acronyms, over 400 and abbreviations used when we talk about 802.11. 400, yeah, 400, not 400. About 50 of those are used regularly by engineers and technicians, okay? So wireless is an incredibly rewarding and rich area if you're a curious person, if you really want to understand, if you want to add value to yourself as an engineer. Wireless is absolutely fantastic, but it has its challenges, and one of those is that it's in a constant state of flux. So let's get a little bit look a little bit deeper over here. We tend to say that good wireless depends on good wire. Good wireless depends on good wire. What do we mean by that? We mean that a good network, a good wired network, is the foundation for you to build a robust and scalable wireless network, right? Because even though we're talking about wireless networks, remember, it's only from the edge, it's only from your device to that access point. That part is wireless. Yes, we're going to be talking about WDS just now a little bit further than that. But generally speaking, it's from your mobile device, from your tablet, from your, whatever device you have, wireless to something that's wired. In my house, all the devices I have around are all wireless. But at some point in time, that black box that comes from BT, it has an Ethernet cable going into it. That's just my home. But if you're a hospital, if you're a school, and you have 20 classes and each class has 20 or 30 computers in it, good wireless has to be underpinned by a good wired network. Never forget that. Never think that wireless is just about wireless. Don't think that you can just understand wireless and you don't have to know anything about networking because you're going to be a specialist in wireless. No. You need to know your stuff. You need to know how wired networks work. But it all starts with the client. So we're going to work on the edge and we'll work backwards, right? So you have your clients. The clients, They could be, like we said, mobile phone, tablet, laptop, anything wireless, a baby monitor, a security alarm, a hotel lock. It could be so many things today. IoT could be a dozen different things today. So those are the clients that are going to need this wireless access. And they are going to connect, of course, to access points, right? They're going to connect to access points. Now, those access points, they're not like the sun, just suspended in midair. Those access points, like when you go to a hotel, like when you go to a hospital, even though you look up and you just see an access point on the ceiling, don't think because it's just there on the ceiling that it's wireless. It's probably, or most probably, got an Ethernet cable running in the plenum, in the ceiling above that device, got an access cable or an Ethernet cable plugging into that access point. So you just see the nice little white box sitting there on the roof or on the ceiling, but behind it is a wired network. And where does that wire go to, right? That wire that you don't see, where does it go to? Well, it connects that access point to a switch. It's on a local LAN, right? So a hospital, again, you might have 10 floors of a hospital. Floor 1 has all these access points, throughout the ceilings, throughout the different wards, operating theater. They have access points. All of those access points are wired. All of those wires end up on a switch. In a hospital, you're going to have maybe 5, 6, 7, 8 switches per floor, and those switches are connected to other switches, and ultimately it could be then connected to a controller that controls all of those wireless access points. Extreme has physical controllers, actual boxes that we call them controllers, and we also have another solution, which is where the controller lives inside the cloud. We call that Extreme IQ, Extreme Cloud IQ. And so the controller moves from a physical device and it goes up into the cloud. It's not for everybody. Of course, there are customers who say, no, we don't want any cloud management. No problem. We have the solution where you have, controllers that are not managed from the cloud or on-prem controllers. So it doesn't really matter. You can have either. But it's the clients sitting on the edge. It's the access points that are going to be talking to those clients. Remember, it could be internal, external access points. It could be any one of those. But the wire that going into your local switches, and the combination of how those switches work and the connecting back to controller, that's very important. At the end of the day, on the other side of all of those controllers, you are going to have servers, okay? You are going to have servers. What's a server? It's a powerful computer, normally not for users, but to run organizations, to run certain features. In this case, these servers, maybe one, maybe more, in a large organization, each one of these that I'm going to be talking about will be an individual server in itself. But in this case, I'm going to just kind of animate it as if it's one server. But that server will offer DHCP. What's DHCP? Dynamic Host Configuration Protocol. That's when a device connects to the network, it needs an IP address. DHCP is in charge of getting that IP address out to that device, whatever that device may be, from a printer to a mobile phone. So that's one of the services that needs to run on these servers. Another service that needs to run, of course, is DNS. What's DNS? We saw that in the example of the Instagram in episode 2 or 3 or 4, something like that, of course 1. Domain name server. That's what takes www.extremenetworks.com and converts that into a telephone number, into an IP address, that those clients that you see, they can use that IP address to get to that website that you're looking for, extremenetworks.com / whatever it might be. Yes, so that's a service. Another service is going to be Radius for security purposes. If you're a doctor, a nurse, if you work in a hospital, when you log on, you're going to have to put in credentials. They can be checked wirelessly. They can be checked against the radius server. Why do we call it radius? Does it mean it's a round server? No. It's got nothing to do with it. It just stands for Remote Access Dial-In User Service. It's like the name kind of is really old, but the technology isn't. But it was a way for users in the old days with modems and things like that, when they dialed into the ISP, this service would authenticate who they were, checking the credentials against the database. So radius server does the same thing. You pass your credentials to the radius server, it goes to check that those credentials are valid, that you are a staff member of that particular hotel or hospital, and then it passes the authentication onto you, and it says, cool, you're allowed to use our resources. So sometimes that can be an individual server on itself, depending on the size of the network, or it could be a service running on a server. It depends on the size of your network. The other one that is really important is NTP. Now, for those of you who don't know, Network Time Protocol, that's what it stands for, Network Time Protocol. It is, if you don't switch on, in fact, I'll tell you a story. A couple of days ago, I have a Mac laptop that I haven't used in a while. It's probably a year I haven't used that. I thought, let me bring it on because I needed to use it for something. And I switched it on, and when I switched it on, it couldn't connect to anything. I was like, man, it used to work. Why can't it connect to anything? And the reason was I knew about it, but it was like, it took me a minute to realize it. When I went to look at the date, it had reset the date to 1980 or something like that. I can't quite remember what it was, but it reset. It hadn't been used in such a long time that it kind of reset the date. Now, you might, as an engineer, you might have come across this before, right? If your time or your date is out of sync. So if you've got a laptop and your laptop, let's say you purposely go set your laptop to last year, and then you try and connect to your corporate account, your corporate account is going to say, and you think, but my password is right. Everything is right. Why won't it connect? Because the time is wrong. It's just like, nope, you can't connect to me. That is wrong. And so most networks today, most big networks, certainly Extreme Networks, certainly everybody, any company on the size of Extreme, or even smaller than that, will use NTP, a time service, to synchronize the clocks on every single device within your network. So all devices, from mobile phones, from your watch, to all of these electronic devices, they all synchronize to an NTP server. Some of those are open NTP servers. The governments put them up and anybody can use them. Atomic clocks, basically. Others, you can buy an NTP server. In the company I worked for previously, we bought our own little NTP box, and it had an external antenna, that got its beacon from some or other, atomic service here in the UK. And then we used all our servers to synchronize off that particular NTP. So it's very, very important to keep all of these things up to date, to keep them all on time, to keep all the clocks absolutely synchronized, NTP. So these are the things that you need. The front end, that's the wireless piece. Those edge clients, that's the edge. But that's just one piece of this whole wireless thing. If your NTP is not working properly, trust me, your network will have issues. If DNS is not working properly, you will have issues. If DHCP, oh my word, if that's not working properly, you will have issues. So think about this, put this in your mind. A good Wi-Fi network needs good wired network. Very important. Another term that you're going to use, or that you're going to hear people talk about, is wireless mesh. Marketers kind of, Google and a number of them make mesh products, and they kind of play a little bit with that term mesh. But you get dynamic mesh and static mesh. It's part of the term for it, the proper term for it is WDS. a wireless distribution system, WDS, wireless distribution system. And the idea behind this is it allows you to connect your network in disparate locations together, just using wireless a mesh, APs, okay, access points. So these access points, they support 2.4 gigahertz, they support 5 gigahertz as well. So they can be used to create this mesh network, and it's secure, right? Because as these access points negotiate with each other, they negotiate what we call pairwise master keys, and they encrypt all the data so that there's, I think I might have just lost connection. So they encrypt all the data so that there's nothing that's sent in open text, right? And so this mesh network allows you to connect these two networks together. Now, why would this be useful? Think about this example, right? You have an office, you have a whole lot of wireless access points, you have a wireless controller, and then you have a warehouse, for example, and you're using WDS, this mesh network, to kind of connect those two areas together. Makes sense, like kind of like with a directional antenna. Probably you'll do something like this. But we got a minute. Let me ask you a question. Where do you think these types of networks might be useful, or why might this type of network, mesh network, we just take these things and just connect them together, right? When I was in the States traveling once, I stayed at a B&B, and the lady who owned the B&B, she showed me her wireless network, and she had a couple of these mesh things. I think it was from Google, and basically you configure one of them. You just configure the one, and then you open the box, take the other one, just plug it in, and it automatically connects, right? And then you take the third one, you connect that, and it automatically connects. And so you're not running wires, Ethernet cables to each one of those access points. You kind of create a mesh network so that the wireless signal carries from one to the other. So think about where these use cases, where these things could be useful. Let me just switch back to my pen. There we go. All right. So let's look at some of these ideas. WDS topology, a simple mesh wireless network. So what is that? It's used when a wireless AP is installed in a remote location, but it can't be wired to the distribution system. Remember in that term we spoke about, what's a distribution system? Well, that's the back end, the wired back end. So in this example, here is my wired device. Okay, I have a wireless a switch, which means it's got a network connection somewhere, and then that has a physical cable into my my access point. But now I want to install this one, and for some reason I can't run a cable to this, and that could be historical buildings. That happens a lot in the UK. There's a historical building, a grade A listed home or whatever. You're not allowed to drill into the walls. You can't chase a cable into that wall. It's not allowed. It's not permitted to do. A very historical building. Can you imagine Buckingham Palace? Oh, let's just drill holes into here and just plug. It's not going to happen. So in cases like that, you might need to put an access point into there and use a kind of a mesh system. So you want it to carry the signal, but without having a physical cable. So this one here, that there would be called the root, or the mesh portal, or the mesh portal access point. The first one that's still connected, that would be called the root or the mesh portal wireless access point. And this one here would then be the satellite or the mesh access point, right? So one is the root, the other one is the satellite, and that satellite is the one that provides that. So in a listed house, you would have your internet connection coming into the house, you'd have a switch, then you'd have a cable that would run maybe along your skirting, along the carpet, whatever, to an access point, and then in the other room, you couldn't do that. You can't run a cable through to that. So you might have located strategically so that this access point can talk to this one and carry the traffic from the people sitting in that particular room. It's time for that 1 minute break. 60 seconds. Get up, stretch, you know the drill. 1 minute, let's go. Good for you. Good stretch there. Okay, let's go back into here. So we've got the terminology right. Okay, let's go on to the next one now. If there is an access point between the root and the satellite access point, it's used to relay the traffic, okay, between the root and the destination satellite. So we would call that a repeater, a wireless repeater, okay? So let's look at this sketch over here. There we go. So I have my wireless devices. I have the same. I have the switch. I have the root, yes, the one that's wired into the network over here. Then this one is the satellite, same as that, right? This is the one that broadcasts the traffic and carries the traffic from the wireless clients upwards. But this one here is just a repeater. So it takes the traffic from this side and hands it over to this side. Takes the traffic from here and hands it over to there. And why do we do this? We could do this to extend range, for example. You know, if you have a lot of distance where you can't get network cables, you can't run them over the ceiling, you can't run them through the walls, there's just no ways to do that, then you can use repeaters in the middle to carry that signal from one to the other. We recommend that in a wireless repeater configuration like I've just showed you here, you should limit the number of repeaters to 3. 1, 2, 3, okay, for optimal performance. Not more than that. Try not to have more than 3. The next one we're going to talk about is what we call a wireless bridge configuration. So if you wanted to join up 2 wireless networks, not just clients, but here you can see we have wireless clients, but they have a router there, right? So you want to route the data from here, from this network to that network. Then we talk about a wireless bridge configuration, and the mesh AP, this mesh AP can only be configured to one of root. So you can't configure it to 2, but you can do it in this particular way, and you can shift all the traffic from one network through one of these satellite or workgroup access points to another network. Now you have a little bit of things that you need to be careful over here. You need to make sure that there is no way that there's any wired connection to that network. Otherwise, you're going to end up with loops, okay? And a mesh network has no ability to detect loops. As far as I know, it has no ability to detect loops. So it really does have to be completely separate network. It can't have any backdoor connections to this one, or otherwise you're going to have a real big, really big trouble. We say that, oops, oh my word. Oh, Isaac, don't do that with your mouse. So what we say over here is, let me just get this up here, that you shouldn't have for mesh networks, you should be limited. It is recommended to limit to, it should be limited to 8 APs per tree, yeah, with the root, and then 8 APs per tree, with a maximum of 3 acting as repeaters, for example, and for data, and use only 2 APs per tree, including the root, if you're carrying voice. So if you're carrying voice, you need, you need less latency, you need you need more quality, right? If you're carrying voice, it's gonna keep dropping like that. Not so good, right? So for voice, 2, but for data up to 8. The limit of APs participating in a mesh tree, in a complete mesh tree, the limit of APs is 50. Okay, limit of APs in a total mesh tree is 50 devices. So I hope that's been really useful, and I will come back on this. I just need to get a glass of water. I should have taken it during my break. I'm not going to spend a lot of time on this. I think we covered this already in course 1. We know the IEEE, Institute of Electronic and Electrical Engineers, they set the standards, and one of the standards that they do is 802. And the rest of the standards for wireless is the 802.11, the working group. So there we go here. There we go. So 802.1 management, okay? 802.3 is about Ethernet. So if you want to know anything about Ethernet, the laws governing Ethernet, or the regulations, the technology, let's call it maybe the technology that governs Ethernet, how it works, you will find them in 802.11, 802.3. 802.5 is an older legacy network. We used to call it token ring, invented by IBM. Everything to do with that particular range of technologies, 802.5. I haven't seen an installation of token ring for easily 10-15 years, probably even more than that. And then you get the 802.11. This is our bread and butter, right? 802.11. Lots of them. 802.11, A, B, G, N, A, C, A, X. Lots of those. But 802, what you need to remember from all of this is 802.11 covers all of those wireless standards over there. All right. 802.2 is talking about the combination of those wired and wireless protocols and standards. 802.2, so it talks about all of those as a holistic group rather than breaking them up into small little chunks. Here, for those of you who want, here's a great opportunity to take a screenshot giving you facts, right? The most important standards, 802.11n, that came this one here. So this was one of the most important standards, because there it introduced the concept of multiple input, multiple output, and that was very important and very significant. Also the speed, that was when there was a really big jump in speed, and we went from something like 54 to 600. Of course, we then had the 11AC in 2014, and this one is the current one, 2019, developed or published in 2019. Each one of these introduced layers. Okay, that's basically what it was. The first, or the initial focus, on a lot of this technology was to do with the initial focus was a lot to do with speed, increasing the speed of wireless, because you can imagine at 2 megabit per second, yeah, it's great to have that, but I mean, a baby monitor possibly works, but yeah, on an enterprise network, not so much, right? And then, you know, we started to jump up in speeds, and there we started to talk, you know, real speeds, 6.7, you know, now we're talking, you know, 10 gigabits per second. Now remember, again, this is lab conditions. This is not in real life. Why? Because simply there's a lot of overhead that happens in wireless, so we don't get to those types of standards in a real world example. But every layer added on the previous one. The focus initially was on speed, getting the speed up, but there came a point where you start to ask, well, it's not so much about speed anymore, right? Wi-Fi 6, for example, is not so much about speed. Think about a highway. I think I might have a video that I'll show you a little bit later. Yeah. Let me show you this video, but let me talk first and then I'll show you the video. Think about a highway, say a 3-lane highway or a 4-lane highway, and think about what that looks like. Let's say maybe 4 o'clock in the morning, yeah, say in Cambridge, 3 or 4 o'clock in the morning in Cambridge. I actually filmed this, I think it was on a Sunday afternoon. You have all this bandwidth, you have these 3 lanes, and you have the cars traveling down there, but there's a speed limit, and the speed limit says 60 miles an hour. But because there's a lot of lanes, a lot of bandwidth, there's not a lot of cars. So they can travel easily at 60 miles an hour, but there's massive gaps between all of them because there's not a lot of them. On a Monday morning, when everybody goes back to work, for example, at 7 o'clock in the morning, if you go back to that highway, what happens? Well, the cars are maybe not moving at 60 miles an hour, but they're more tightly packed, right? And so instead of being big gaps between the cars, the gaps are now much smaller. Maybe they're not traveling at 60 miles, maybe they're traveling at 50, but now the highways are being used much more efficiently. The bandwidth is being used much more efficiently. And so that has been more the focus of AX, rather than just concentrating on pure speed, saying, hey, there's a lot of bandwidth over here that's not being used very efficiently. Let's make better use of this. That's kind of where we're going over here now. Let's look at this in terms of standards. And here we have, again, the 2.4. Remember, we know about this 2.4 and 5. And now we have the 6 gigahertz as well. Starting here, 2 megabit per second, and going here in 2018, 2019 to 10 gigabits per second. You can see that this thing has been in a constant change, state of flux, right? These two close to each other, 11 and 54. Then, 300 goes to 600, 1.3, big jump to 1.7, big jump to 6.7, another big jump to 10. Where are we going next? Well, there's big improvements coming. There always is. As long as there's a demand, there's going to be an improvement. The other thing that is important to talk about over here is sometimes a standard will come out like 802.11ax. 2019 it came out. But only now are we starting to see companies starting to implement these, right? Extreme Wireless has already had Wi-Fi 6 devices for quite a while, But I think up till now, only the new, in Apple's world, only the new M processor from Apple, only that device supports AX. All the other devices, their laptops, desktops, all of those, they don't support AX. So even though we're in 2021, and this standard was done in 2019, we still have tons of devices that don't talk AX. So you can often see that these standards have very long shelf lives, and people keep going for a long time. And that's also one of the disadvantages, because people go and install a wireless network and they have, these barcode scanners, for example, and these things were, sold 10, 15, 20 years ago, and they only support 802, 11B, for example, or 11A. And you want to put new technologies, but these things are holding you back, right? Now, all of these things are backward compatible, but it's still holding back your network, right? So oftentimes, if you drop 2.4 and move all the devices to 5, you'd have a much faster network, right? Because there's so many legacy devices on 2.4. It's much busier on the 2.4 range than on the 5. But if you could move everybody to 5, everybody would have a better experience. And the same to 6. But it needs the hardware to catch up. So I think Apple's, the latest iPhones now support AX as well. I think 11 might have, in Apple's case, the 11 might have, and I think the previous Galaxy as well already supported AX. So some of these technologies, even though they're released in a particular year, they take some time before they catch up and before everybody is using them. But if you were doing a new installation today, if you were watching this and thinking, oh, you know what, I want to get some access points, I'm going to put in new wireless access, then without a doubt, put in 802.11ax access points, because they are backward compatible with everything that's been previously put out. So that backward compatible with your Macs and all of that, but they also forward compatible with all the new stuff that will be coming out that will have AX. That's one of the important things about being up to date, is you get your backward compatibility, but you open up to a whole new range of products that will be released onto the market. What's coming next? Well, 2022 B 802.11-B-W, 2024, we're talking about 802.11be Wi-Fi 7. It's a while away. They're obviously still already working on this type of technology. A lot of these technologies are not revolution, right? These updates are not revolution. They're mostly evolution. But that's good, right? That's good. As long as they're backward compatible, I don't care if they're revolution or evolution, as long as we keep developing and we keep growing. Here's another one for you to take a screenshot of, just giving you different standards, etc., etc. Now, let's get ready to land. This will be the last module for today. And let's talk a little bit about the physical layer. We've dealt with the physical layer when we spoke about it in course 1. So please, I'm going to give you the slide. If you go to Meeting Pulse, Claire will have the URL over here, but if you go to Meeting Pulse under the Materials tab, this slide I'm going to give to you. I know we say we don't give anybody slides, but this slide I will give to you, because it's just no ways that you can read it, no matter what size screen that you have there. What is this showing you over here? Lots of colors? Yes, that too. But this is the electromagnetic spectrum. Okay, this is the electromagnetic spectrum. You can see it's a little bit busy, right? You can see that it's a little bit busy. All these bands, look at that. That's 30 gigahertz, 3 gigahertz, 300 megahertz, 30, 3 megahertz, 300 kilohertz. I don't even know what 3 kilohertz. Each one of these bands of frequencies have allocations in them for different things, for all sorts of different things. So when we talk about the 2.4 gigahertz spectrum, it's a range of frequencies within 2.4 gigahertz, and then they are split up and allocated to different things. You can see that radio spectrum is a busy thing, and you can see why we need to have regulation. Again, I'm not going to be reading this slide to you, or spending a lot of time on this slide. Screenshot it if you want. It contains interesting information on here. Everything from industrial, scientific, medical purposes, other types of communication, ISM bands. These, you can see the frequency range that are allocated to all of those things. Now, governments around the world, they sell Wi-Fi spectrum, or they open it up. Generally for mobile carriers, they sell that spectrum. I think for wireless, they just open it up. So a regulator like the FCC will say, okay, in the US, we're going to open up the 6 gigahertz band. I know Brazil did this recently, and I think it might have been Dubai or one of the Emirates did this recently. They opened up the entire spectrum for wireless and say, well, that whole range, in this case 5.925 to 7.125, that whole range is going to be made available for wireless. But here you can see this is the one where this is the busiest, right? It's natural that it's the busiest because it's been the one that's been used the most. It's had the most traffic over the years. 5 gigahertz, of course, is nowhere as busy as 2.4, but of course most devices are going to start going across to the 5 gigahertz, and then this is the new one, right? And N, AC, and AX, all of those work on the 6 gigahertz spectrum. So any device that is compatible with those particular standards will work on the 6 gigahertz. Microwaves, radar bands, these are quite important. 3 meters. I think that is not 3 meters over there. I'm not sure that this is correct. I'll have to verify that. There's, FM broadcast. Claire, can you just make a note of this slide 97? I don't think that this is correct. Anyway, we have terms for these. Very high frequency, VHF, UHF, super high frequency, and extremely high frequency. I don't know what the other ones are. Ultra super, ultra super squared. I don't know. Unlicensed spectrum and challenge and channel allocations. So this is also really important, because in the different spectrums you have different channels, right? You have various channels. They're categorized not just as we don't talk about them as frequencies. We talk about them as channel, and a channel will be a range of frequencies, and that goes within this channel. So it is recommended, we generally say it's important to place APs based on signal strength, not distance. That makes sense, right? It's recommended to place APs about 70 dBm apart. Now, if you have the right tools, that's quite easy to do. You should always avoid placing APs on the same channel number next to each other. So if you have a number of access points, don't put all of them on channel 11. The 2.4 gigahertz range only has 3 non-overlapping channel 1, channel 6, and channel 11. So if you place access points on those, then there's no overlap between them. So first one on channel 1, next one channel 6, next one channel 11, next one channel 1, channel 6, channel 11, right? That's how you would set them up. Don't put everything on the same channel. The 5 gigahertz range has upward of about 19 or just over 19 non-overlapping 20 megahertz channels, ranges, particular ranges. So where 2.4 has 3, 5 has 19. So you can see how you can divide it up a whole lot better. 6 gigahertz has 59 non-overlapping 20 megahertz channels. So So that's important to think about, right? When you're doing networks, think about that. Think about how you structure your wireless networks, how you allocate the channels into your wireless networks. I keep hitting this mouse and it just keeps going ballistic today. CCI, co-channel interference. Just like in electrical, you place two electrical wires, there's going to be some electromagnetic interference between there. The same thing happens when you do wireless, right? CCI is when transmissions occur on the same frequency in the same area. We also call that overlapping basic service set. ACI, okay, another term, occurs when transmissions are sent on an adjacent or partially overlapping channels. So APs on the same channel will hear each other and differ. For example, if you have an AP1 on channel 6, it hears the preamble transmission of a nearby AP, AP2, for example, also transmitting on channel 6. AP1 then differs and cannot transmit at the same time. So you see, it's like, you must, you go, I go. So all the clients associated to AP1 must also defer transmission if they want to hear the preamble transmission on AP2. So it's really important that we understand this. These are, again, terms that you get your head around. Please go and look at adjacent channel interference, ACI, and co-channel interference. Read, because if there's one mistake that that people make, two very obvious mistakes that inexperienced engineers make is, number one, they put all the APs on the same channel. They think, oh no, it's the same. I need the same SSID, so I'm going to put 10 access points. I'll put them all on channel 6. No, don't do that. Change those channels, as I spoke about. Change those, put them 1, 6, 11, 1, 6, 11. That's one of the very important things. The other big mistake that everybody makes is, oh, these there's not enough coverage in here. I've got 2 access points or 3 access. Let me turn up the power to maximum, right? Another big mistake. Less is better. So get your head around this. This is very important. One more term that we're going to be talking about, and that is DFS, okay? Dynamic frequency selection. Dynamic frequency selection. So in many countries, I would say probably every country in the world, I don't know of anyone that doesn't, but there certainly might be, regulatory requirements will limit the number of 5 gigahertz channels. So even though there is a 5 gigahertz spectrum available for wireless, there might be some channels that they are limited there. And those are for military radar systems. Now, it's unlikely that you're going to have a radar in your office, right? Or in your garden, a government radar in your garden. But governments reserve the right to overwrite that particular space. So it's very clear what the standards are. It's in the 802.11h standard. It addresses these particular channels, and it's channels that, should the government want to use those channels for radar events, and it could be things like detecting earthquakes or whatever it is, should they require the usage, should they need to communicate on that, then your devices, if they are using those channels, if they hear any information being broadcast on there, they have to step back, right? They have to step back and go use something else. So the government doesn't say those channels are for us and you're not allowed to use it, because they understand that that's a lot of spectrum, and for a lot of the time those channels are not going to be used. There's nothing that's really going on those particular channels. So what they'll do is they'll say, you're free to use them, but your device, to comply with my regulations or the regulation within Europe, must stand back if it hears broadcasts on these particular channels. Okay, keep that in mind. That's really important. If you have devices that are absolutely mission critical, that they cannot be down for a millisecond, then it would probably make sense to allocate them to a static channel so that they don't roam, you allocate them to a static channel so that they are never interfere with us outside of this range of the DFS channels. Something interesting, I had no idea about this, but the things that you learn on wireless. Now, before I knock off, I want to tell you a couple of things. This course and the one that came before it is about educating you about wireless, about networking, etc., etc. But we have Nabil Bukhari, who is the Chief Technology Officer at Extreme Networks. Guy is an absolute genius. And they have made a podcast. The office of the CTO have made a podcast. They call it Inflection Points. Inflection Points. Okay. If you go and search for it on your podcasting application, or if you go to our YouTube channel on YouTube, so you go to YouTube, you'll see it's like yellow and purple. Really cool. It's Carlo Gazzetti. I think that's how you pronounce it. Guzzetti and Tim Harrison. They run that podcast, and they don't talk really so much about existing technologies. They talk about, so Nabil came up with this concept called the infinite network, right? It's an incredible term. It's really gets you thinking about networking and what is the future of offices and enterprises when it comes to networking, right? The world has changed. Every person who works from home now is part of your extended network. It's an infinite network now. And so they discuss these really interesting, to get you thinking about networking, the future of networking, how Extreme Networks is thinking about networking. So I really want to encourage you to go, to click. I think there's a URL. There might be a URL or something like that. Just scan it or go to it or do a search for it. Inflection Points podcast from Extreme Networks. Type that into your search engine, and it's so well produced. It's really, really good. It's interesting. It's not as long as my stuff. My stuff is really long, but theirs is short and sweet, and it gets to the point, and it's excellent. So I really recommend that you do that, number one. The other thing is what I said in the beginning. If you don't have a LinkedIn account, go get yourself a LinkedIn account. This is good for you, for you. And if you need to communicate with me, you want to, whatever, go to LinkedIn, just, make me follow me or just connect with me or whatever. And then, just tell me that you watch Extreme Academy, and we'll connect, and I'll be a follower, and we can chat on there when I can and how I can. So that's the other thing. Third thing I wanted to encourage you is learning is a continual process. It's not something you do once and it finishes. It's a continual process. So on a Extreme YouTube site, we're trying to get, more and more people to subscribe to that site. It does send you notifications, like, it sends you notifications about Extreme and when new videos are posted. We're not posting every day, so you're not going to get 10,000 notifications from us, but it would really help us. Do us a favor. If you would go on, there's like, I don't know, 200-300 or whatever people, connected to this. If you would go on, if you're not subscribed, hit that subscribe button. You do me a favor. Thank you. I say thank you. Thank you so much. If you can do that. Fourth thing that I wanted to say is this. We've looked at kind of the stats of the people who watch Extreme Academy, and it really breaks my heart that only about 11 to 12% of the people who watch are females, right? And there should be absolutely no reason why those numbers are so low. Females, girls, women, they're just as good as this stuff as anybody. I've seen such great female engineers on here. So I encourage you, if you have a friend, if you have a colleague at work, if you have a family member that might be thinking of going into networking, why don't you ask them, go watch this. Maybe this will be of interest to you, because it's such a fantastic career. I'd love to see the numbers of of women who watch this course go up. That would really be nice, that Extreme Networks may is able to do something that nobody else does, and that's to get more women involved in networking, because it's an absolutely great career. So other than that, thank you so much for watching. Next week we got some guests, some awesome guests. Watch LinkedIn. I'll make the announcement on LinkedIn, and you'll know who it is. You'll definitely want to watch. The guys are going to come on next week. It's going to be very, very good. So thank you once again for watching. Really appreciate all of you. Hit that subscribe button if you have time. Doesn't have to be now. Go later. Go look at some of the other videos that we have. Go listen to the podcast when you're driving. If you're on the train, tube to work, put in that podcast, listen to it. Get you thinking about networks, about what's coming up, what's down the pipe, what do you need to be aware of. Superb. Promise you won't regret it. Thank you. See you next week. Same time, same place. Keep safe.